Okay, so last but not least, before lunch, we have a use case. So we're gonna get started. Um, Please take a seat or yes. Okay, ready? Yes, yes. Okay. So I guess everyone is now worried about cybersecurity, going to check their systems or are getting hungry. But before we break for lunch, we have a use case for you. We're going to talk about how AutoML might actually help us against fraud. And to talk about this, we have a speaker, Ashkar Gobani, who's a lead data scientist from H2O AI. Welcome, Ashkar.
So hello, everyone. Thank you. So for those that are sitting on the back, no pressure if you want to check your emails. But if you want to see the slides, it's easier if you come closer. Because I tested this morning, it's not easy to see from the back. But anyway, today I'll be speaking about fraud and specifically how, with the help of a real case use case, that we have worked, how machine learning can help in fight against fraud. The specific problem with the fraud is that it's a very big issue. So the cost of fraud globally is 5% of global GDP, which is, if you want to compare, it's bigger than the size of Germany's economy, Europe's biggest economy. So that's a really big problem. And another problem with this is that this problem getting even bigger every year. It makes sense. We do a lot of more, we move a lot now in a digital world on the cloud, and we just create more opportunity for fraudster. And one interesting fact about fight against fraud is that in order to eliminate that problem, we created even bigger problem. Now the fight, the effort to fight against fraud cost us 3 times more than the fraud itself. It's like we want to solve a problem, and we ask politicians to help us how to solve a problem. You want to solve a problem? Create a bigger problem. People will forget about the original problem. And that works, because what I'm going to do, I'll forget about fraud and deal how we can fix the problem that we have created. The fraud detection systems, how we can help fraud detection system not be as costly as are today. So just going back to the previous slide, one point about this is that the majority of this issue that we see here, why it's so costly, is the thing that we every day are also experiencing that. You use, for example, your credit card, you're doing a legitimate transaction, but it's been declined for many reasons. And this is called false positives, false alarm. So these systems has lots of false alarms, and the biggest portion of this cost comes from these false alarms. And this is something that we're going to target address today. So let's have a look how the fraud detection systems work. In the previous sessions, we have heard about deep learning is the cool stuff, but the fraud detection system in reality today is based on rule-based engines. So how they work, you use your credit card, and it initiates an event in the back. In the payment processing system, and it asks questions like, okay, is that a physical credit card? When was if yes, then when was for example, the last time that this has been used? If it was a few minutes ago, what was the distance, physical distance? So if it's like, 2 minutes ago, the credit card's been used in 100 kilometers away, that doesn't make sense. So then the action would be decline it. So that's how a rule-based system works. And why people like it, because it's very fast. When you do the transactions, for example, online, in sub-second, you want to have the score, whether that's fraudulent or not. So that's why these rule-based systems are also popular, and also they are transparent. Everyone understands if a transactions decline, we know why. If you use deep learning, it would be difficult to ask that question, why it's been declined. So that's why they are popular. So then what is the issue? it's not accurate. And that's, I guess, becomes a bit difficult to read, but I will explain to you. It's low accuracy, they're not accurate, and in order to compensate that lack of accuracy, they become more and more conservative, meaning generating lots of false positives. False positive again mean that a transaction is legitimate but will be flagged as fraud, and someone needs to go and look at it manually. They're not flexible, so and we know that the way that people commit fraud is changing, they're adapting. So if the type of fraud changes, it takes time until people go and analyze that fraud and extract rules and incorporate rules into this system. So that takes also time, and that's why we are always behind how people do the fraud. And other characteristic of these systems is that they are using limited amount of information that is available in the organization. And again, in previous track, we've seen that there's lots of information available in organization, but we are not looking into it. Even as simple as the historical behavior of a card owner, we even don't use that in many of these systems to understand that is that a typical behavior of that specific person. And I'm sure that you're doing things very standard purchasing, but all of a sudden it becomes blocked by the system. One example I had just a few weeks ago, I booked a flight to south of Italy. I booked a hotel. What would I book the next thing that I'm going to book for a vacation? Cars. And this company knows me for years. So he could even suggest me what car I could book, but they declined it. So that credit card goes to the back of my wallet, and I've not used it since then. So, and that really happens. 30% of the users, if it rejects or declines or blocks, it will go back. They will not use that credit card. So now we want to fix that problem or improve it at least. What would be the characteristic of a solution that we want to now offer? It needs to be able to look at a variety of, I go a little bit so people can see. So we need to be able to, or the system needs to be able to analyze the more data that we have in organizations or in the institutions, meaning that, as simple as that, look at a historical transaction of a person and extract signals from that so that it can be used in the whatever model that we are going to use to detect fraud. And indeed, there was a study from MIT AI's lab that if we just used the historical transaction of a person, that could reduce false positive by more than 50%. So improving accuracy is one thing that we obviously need to focus on, and the big portion of that needs to be reducing false positives so that we can manage the cost. Trust, again, we have heard it in previous session, anything in financial institution, thank you so much, needs to be transparent. So any model that we are going to apply, we can now simply use state-of-the-art deep learning in applying, if the model says that, okay, this is a fraud, and if you ask question why it comes to that conclusion, if you cannot answer that, we can now use it in the financial institution settings. And last but not least, it needs to be fast. We cannot come up with a complex solution that is perfect, but it takes half an hour before we get the answer. When someone clicks purchase, it's less than a second. We need to have the answer whether that's a legitimate transaction or not. So now the problem is getting a striking balance between all these requirements. This is sort of the problem that we are actually working with a big financial institution to solve this sort of problem. And what we're going to do today is walk through one example, and that would be credit card fraud detection for one of the US largest financial institution. So what they, obviously, for obvious reason, I cannot name who the company is, but this is one of the US biggest financial institution, and they have the similar problem again. and significant of the payment processing that they do will be flagged as, or used to be flagged as fraud. And a big portion of, again, that flagged fraud was false positive, which needed to be reviewed manually. Now, the solution that the requirements that this specific customer wanted to have is that reducing fraud, obviously by detecting frauds more accurately, while reducing false positive at the same time, so that they save investigation time. And obviously that one is the pre-requirement, I would say, that being able to generate features, lots of features from the existing transactional, personal information that people have, and from previous interactions that they had. So a simple sketch of the solution that they had was something like this. So if transactions come through, it goes through a rule-based engine, and based on the rules, whether it goes through as okay or not okay, which then someone manually will go and process that, reviews whether it's really a fraud or not. And as you can see in this plot, the majority of those that gets okay is really legitimate transaction. A small portion is fraudulent. And part of that fraudulent transactions will be reported sometime in the future. Sometimes we don't even know that a fraud has happened. So that's also a difference between the frauds that we don't detect. And then, as mentioned already, again, when a transaction flagged as not okay, if you look at those, the majority of those, as mentioned many times today, will be not fraud, and they are false positive. And this number is not from this specific client, but in the US, it's been estimated that credit card fraud itself is $9 billion, but the false positive cost is more than 100 billion, it's like more than 10 times. And this specific financial institution had the similar observation. So what they have done here, how many of you are data scientists here? What is the, if someone told you that I'm going to rent you a data labeler, how thrilled you would be. So we have a data labeler here, and who is? Guess, this person. This labels the data. Any transaction that sets alarm, it reviews and say that was that transaction was real fraud or it was false positive. So it generates. So many financial institutions are already generating big portion of labeled data that can be used for creating a machine learning model to detect that if a rule-based engine alerts us, is that real fraud or not? So if the likelihood is really low that this was fraud, it can route back to the OK transaction. And there's another thing that we know, labeled data, those that are reported fraud. From that reported fraud, we can create another model here so that those sort of fraud can be detected. Unidentified fraud will not be detected by this. And in this specific case, we have built anomaly detection in order to identify new types of fraud, and that we don't have historical example for it to create a supervised approach. So now if you look at this, many organizations see this as a low-hanging fruit because they don't need to replace the existing solution, they enhance it. So because due to regulatory requirements and some other stuff, you don't want to really replace that. But you will be able to enhance those, and at least like this specific organization that has done. And what was the outcome? They have been able to reduce false positive by more than 64% and be even more accurate to detect whether a transaction is fraud or not. So the fraud that have been not identified by the rule-based engine, they have been able to reduce by this approach by 50%. So H2AI Cloud is actually a platform to allow us, in in a nutshell, to create these sort of machine learning models. So what it does, it allows us to automatically create these models by automating feature engineering that, for many data science that you see that there's lots of data science here, is a cumbersome task to do. So it's automate that piece and creating models. And finally, managing models that also data science not typically would love to do that, like taking care of putting models in production, monitoring, and those sort of stuff that really, in a financial institution, it's a must-have things. And at the end, you will be able to create a application, if you want to, in order to give access to your business user fraud analyst that you might have and wanted to interact with the models that you have created. So, like this specific case, we are working with many big organizations across the industry, a variety of use cases to address similar use cases like the one that we have seen here to address like fraud detection and things like that. And fraud detection is not only in banks and payment system, also if someone works in telco, don't know the iPhone stealing is one of the biggest fraud that people do, when they're want to get a SIM card or something, or get a contract with a telco company. Yeah, that's it. So feel free, if you want to get more detailed information, join us in our booth, B30, to get more information about AI, or if you find AI is boring and you want to play Mario Kart, for example, feel free to stop by and say hi.
Thank you. I would like to know if this model that you showed us before, if it was used in production, and if it's so, two questions. The first is if there was, at least at the beginning, some kind of human in the loop after the machine learning model inference. And secondly, generally, what was the acceptance from the organization for this specific model, especially the one that green lights some transactions? Thank you.
Yeah, that's a good question, because first thing first, this is a US company, and in Europe things are a little bit different, and I know that here is a bit difficult to deploy machine learning in such a, but it is in production. So they use that to reduce fraud in real production. And the numbers that they have told us, it is from production, not from test data set.
You said that you use outlier detection to find potential new sorts of frauds. How do you label that data? How do you then train the follow-up model to decide whether it's actually fraud or not if you're kind of finding new sorts of fraud?
It's an anomaly detection model that we needed to put it here because we didn't have a label for it, like for the sort of frauds that happens and you don't know. And so basically what it does, it just says that how this specific transaction looks being an outlier compares to the other transactions that this person had, or comparing other transactions that we have. So this doesn't require a label, but it will be routed to, or it routes to non-OK, which someone manually will go and look at it. And if the anomaly is really high, then it will be routed to the not OK, which someone then manually will tag it. But to be honest, I don't know whether they have implemented additional process to improve that model. Not sure.
How do you avoid bias?
Sorry again?
Avoid bias. How do you avoid bias?
So that's the good question, because some of the things that I've not covered here that the platform allows you to, when you build your model, look at biases from a variety of perspectives. Like, for example, there's certain information that you should not have bias, like against genders or things like this. This will be, you can see when you build a model, see if you have a bias or not. Now, how to act, reduce fraud, reduce biases. It's a little bit, it's a process because, if your data is already biased, what you can do about it, it is not an easy workaround for it. You need to have a process. But at least what we helped you to see whether you have a bias in your data set or not.